Hi everybody. My name is Zoe Porter. I'm a research fellow in the Department for Computer Science. My own background, academic background, is in philosophy. I work on the ethics of AI, broadly construed. That includes lots of things around responsibility, autonomy, how to assure systems so that they're ethically acceptable. My work is highly interdisciplinary, so I work with colleagues who have expertise in computer science, software engineering, doctors, lawyers, entrepreneurs, psychologists, all sorts of people. And today I'm going to be talking specifically about the ethics of medical AI or AI in healthcare contexts. And particularly, I mean, when we're talking about medical AI, there's always a focus, or there's often a focus on the impact on the patient. And that's really important. But actually what I'm going to focus on today more is the impact on the clinician, which is equally important and often overlooked. So for those colleagues who are from computer science, they won't need this intro, but for everybody else, it might be helpful just to set the scene a little bit and talk about what AI is and how it began. So even though the sort of historical strands of AI go back to Charles Babbage and Ada Lovelace, and some people even think Leibniz in philosophy and Alan Turing in the 20th century, it's sort of widely agreed that the birth of artificial intelligence was this workshop, this 2-month workshop in Dartmouth in the United States in 1956, where a group of researchers who were working on related problems came together to do a study on artificial intelligence. So this is where the term artificial intelligence was first coined by the two chaps at the top right, Marvin Minsky and John McCarthy. And this, the purpose of this 2-month sort of summer workshop was to, it says here at the bottom, to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can be in principle so precisely described that a machine can be made to simulate it. And that's still the essence of AI today, essentially making machines do what it takes intelligence for human beings to do. And these researchers looked at lots of different problems, like programming computers to use language or to self-improve, that are still really bedrocks of artificial intelligence research today. And a lot of them went on to found major AI research groups at universities like MIT and Stanford. So to continue to set the scene just a little bit, broadly speaking, and this is very broadly speaking, there are 2 types of artificial intelligence. You've got artificial intelligence on the left-hand side, which was sort of dominant until the early years of this century, which is knowledge-based. So the idea is that you take in knowledge, human knowledge, and encode it as a set of rules. And that's how you get machines to simulate human intelligence. So say, for example, if A and B here, imagine you've got a patient with type 2 diabetes. Imagine that A is if A, the patient has very high glucose levels, and B, those have not been controlled over the past 6 months with changes to diet and exercise, then yes, 1, prescribe medication. Otherwise, to continue with diet, and changes to exercise and things like that. So that's knowledge-based. And then on the other side, we've got learning from data, or machine learning. This is sort of machine learning that's really dominated recently, but it goes right back to the early days. And here what happens is data is fed into the system, into the model, which progressively analyzes features of the data and then outputs a classification or a prediction. And then the developer or the programmer looks at those predictions, looks at whether they're accurate to the training data, fine-tunes the model to get it as accurate as possible, and then validates that on a new training data set. And this is very, very useful for tasks and problems where it's not actually that easy to specify a set of rules. And it offers lots of opportunities also for spotting patterns in data that people might not have, sort of seen before. But it also has significant limitations, particularly from an ethical point of view, because even though it can very effectively output classifications and predictions that are accurate, actually not even the experts know exactly how they're doing it. So there's an explainability problem there. And also there's a bias problem because, you know, we are biased, people are biased. So the data that's coming from humans encodes often human bias. And, you know, there's the phrase garbage in, garbage out. So racism in, racism out, sexism in, sexism out. So there are lots of ethical problems with this as well. And there are people working very, very hard to deal with those. So, two recent developments in artificial intelligence, and I'll take this one first because it's actually older, is embedding AI models inside robotic systems. So the classic example is a self-driving car, but there are also maritime vessels, drones, robots in space, under the water, agricultural robots, industrial, that all involve some sort of AI model. I mean, robots don't have to have an AI model in them, but many do, and this is a recent development. So here you'd have, for the self-driving car, AI algorithms that look at path planning, predicting the trajectory of different objects or pedestrians in the domain, for computer vision, so identifying objects, for steering the vehicle and making real-time adjustments. So that's one big development, and actually the research group that I'm in, the Assuring Autonomy International Programme, looks at autonomous systems, which is largely robotic systems. And then the other new development, which if you were alive last year, you will have known about, is ChatGPT, which is really generative AI. So generative AI is based on a new kind of neural network architecture called a transformer model, and it's got a new mechanism which is called an attention mechanism, but it basically allows the model to identify which, say you've got data like words, which ChatGPT is based on its text base, which of those are particularly salient, what the contextual relations are between them, and take lots of, and actually look at the contextual relations between sequences of words, and that gives it a very useful capacity then for when people ask it, prompts like answered questions, and it can generate text that's very plausible and very relevant. And also it's trained on humongous amounts of data, essentially the entire internet. So that's a new development which is extremely significant, so significant that governments around the world are quickly writing legislation to try and deal with it. Right, moving on. So something I'm not going to talk about today is super intelligent AI going rogue. Now, a lot of people do, and particularly some academics like Stuart Russell at the top and some entrepreneurs like Elon Musk at the bottom, they are very, very worried that if AI exceeds human capacities, it's going to be very difficult for us to control it. And this is a live debate. There are a few people who are very, very exercised about it. The mainstream position is that it's not the most pressing concern. There are people who argue against it on philosophical grounds, that it trades on particular notions of intelligence that aren't entirely coherent, or it rests on a philosophy of mind that isn't really, doesn't stand up to scrutiny. That's one set of arguments. Others argue that this is a very low probability event, and we'd be better off focusing on near-term problems, like the bias and the explainability that I was talking about. And then there is sort of a more sceptical set of arguments that this is a sort of perverse form of marketing for AI, and it generates a lot of hype and makes you think that, these machines are going to be so much better than us, and sort of feeds into automation bias and things like that. But I'm not, and there are rebuttals to that, but I'm not going to focus on that element of the ethics of AI today. So what I'm going to focus on is the near-term and existing AI systems that that have been the subject of a huge amount of discussion. There's a huge amount of development and innovation and increasing deployment, and governments around the world are really trying to grapple with this. So last year in November we had the AI Safety Summit. The UK's approach to regulating AI is quite light touch. It's at the moment not trying to impose too many rules. The US is slightly more, taking a slightly stricter approach, and they've recently announced some legislation. The EU is taking a much stronger approach and is setting quite a lot of legal duties for providers of AI systems, and this is a risk-based approach. And medical devices are very much risk-based systems, so they will be subject to an awful lot of regulation. So AI in healthcare, it's a massive area. It's one of the biggest sort of industry growth areas within the industry in terms of development, innovation, investment. It's huge. The UK government's committed hundreds of millions of pounds to it. It's central to the healthcare policy of the current government. It's central to the healthcare policy of the Labour opposition. And there are all sorts of use cases for AI in medicine. But what I'm specifically going to focus on, as quickly as I can, is in bringing AI into the clinical consultation. So the positive story, the vision, as it were, is that by relieving clinicians of burdensome tasks and helping to reduce the gap between demand and capacity in healthcare systems, this will free clinicians up to do the patient-centered work and really consider and understand patient sensitivities and patient preferences. That's the vision. There's also, however, widespread consensus, and it's present consensus. It may change, and even a call I was on with somebody today was about changing one of the things I'm about to mention, but there's widespread consensus that a clinician should always be in the loop, which means that if there are any final decisions to be made about patient treatment or any sort of patient intervention, it really should be a human being making those decisions and not a machine. And the second thing that there's widespread consensus on is that the clinician is responsible for what happens to the patient. But if we think about that a little bit, just a little bit, and think about that positive story and this vision for AI, you can see how there's a risk here of conflict and confusion, because on the one hand, you've got these systems who are so good and which are so good and so accurate that they're sort of as good or better than a human and freeing up that human in the loop to do the patient-centered work. But on the other hand, you're giving that clinician in the loop a new job to do, which is to check a very complicated machine and make sure that whatever recommendations it's putting out, if they're incorrect, they don't get implemented. So there's a bit of a tension there, which means we really need to think carefully about the clinician in the loop and what role they're really playing and how to make sure that they can do their job effectively and serve their patients best. And then also when it comes to the clinician being responsible for what happens, given questions like the explainability issue, if they end up in good faith implementing a recommendation that a clinical AI system makes and that turns out to be wrong, is there a worry then that they're absorbing all of the blame and all of the liability for decision-making across the healthcare system? It's all landing on them. So these are the sorts of ethical questions that we're looking at in two projects. So there's shared care on the left-hand side and assuring responsibility for trustworthy autonomous systems on the right-hand side. In shared care, we're looking quite closely at different ways of integrating AI into the clinical consultation so that really clinicians aren't put in impossible situations like this, to really help them do their job well and so that that positive story can come true. And in the responsibility project, we're looking at the distribution of responsibility across decision-making actors in the AI lifecycle and really looking at how ascriptions or attributions of responsibility to individuals or to institutions can be fair and there aren't these sort of asymmetries of blame that I've just described. So this is one model of integrating AI into the clinical consultation. It seems to be the standard model. So what happens here is the clinician and the patient are having a chat, they're having a dialogue about the patient's situation, symptoms, what treatment they would like, what works best for them. And whilst that's happening, the clinician has inputs from the electronic data, so electronic patient records, non-electronic data, so their own observations of the patient. And then the idea is, in the standard model, that the system outputs a recommendation on what the treatment should be, and then the clinician takes all of that on board and decides whether or not to go with the AI's recommendation or not. But we're quite worried that this standard model is really going to bring up the sorts of problems I was talking about putting the clinician in this difficult situation of trying to interpret, interrogate, be a safeguard on the machine, whilst also navigating patient sensitivities. And there are lots of sort of worries, ethical worries about what impact this could be on the clinician. So in this study that we're doing, we're looking at different models. We're testing different models of AI integration into the clinical consultation using real clinicians. And this is a prototype made by Mohammed, who's here somewhere. So the use case here is diabetes. But the idea is that there are different ways in which, if the clinician were to click on that shared care button, there would be we're looking at different things that the AI might say, and whether that would make it easier or harder for the clinician to be supported by AI in the clinical context. So different models are, rather than the AI system just outputting a recommendation, it could be that it just outputs the explanation but doesn't actually say what the recommendation should be to the patient. Or there's another model where it's the explanation plus the recommendation. And these sorts of things, and we're still testing it, I don't have the results yet, but these sorts of things may actually help the clinician more to decide whether or not to accept the recommendation or not, and just make a more informed decision and actually exercise their own autonomy a bit more. And then there are two other models as well, which at the start of the project seemed futuristic, but now seem very near term, which is where the patient and an AI system, probably not dissimilar to ChatGPT, have their own conversation, and then the clinician's presented either with a transcript that they're supposed to sign off on the recommendation or not, or they bring that into the consulting room and they have a shared conversation. Sorry, I know I'm really running over, so I'm going to go even quicker now. But this is a really interesting thing that we're also trying to tease out of the research, which is this all seems very well and good, but what happens if the clinician and the AI system don't mesh, if they don't agree, And something we're a bit concerned about, which came out of our work with the patient panel, is that lay people, patients, definitely seem to think that it would be more reasonable to agree with the AI than not to agree with the AI. And there's been a study done in the United States where it was shown amongst lay jurors, so just normal members of the population, that actually it even seemed to be more reasonable to agree with a non-standard recommendation from an AI than to reject the AI's decision. So this is quite concerning. It's concerning in terms of what this is going to, if we're not careful, what's this going to push clinicians towards? Is it going to push them towards something called algorithmic deference, where they're essentially not doing what they think is right, but trying to shield themselves from responsibility or liability by going with the machine instead? Now, again, we don't have the results, we haven't got it all, we haven't got all these questions answered, but these are the things we're thinking about in the project. And something I'm particularly concerned about is that rather than get the positive story where you've got this really well-supported clinician, you've actually got someone who's not doing what they think is right for the patient for wider systemic reasons. The ethical implications of that could really mean that it's not a benefit to clinicians at all, but very much a burden. So in order to get that positive story, we need to think really, really carefully about how to integrate AI and not just assume that if you put a very clever machine in the consultation setting, that positive story is going to emerge. All right, thank you.